So my name is Olga. I'm a solutions engineer at Cloudflare. Who knows what Cloudflare is? Okay, couple of people, nice. So Cloudflare is a huge anycast network, right? So we have a global presence, almost 200 data centers now, or points of presence. We have 30 terabytes network capacity, and we can act as a reverse proxy in front of basically any website, any server, on any hosting. The scale of the network can actually allow us to mitigate huge DDoS attacks. We can do caching and many other services. As a solution engineer, I help tech teams of our enterprise customers to basically deploy Cloudflare to their infrastructure or migrate to Cloudflare without any downtime. And we also do customizations of the platform for the customers. And we used to do lots of Lua scripts, because the majority of things are actually in Nginx in Cloudflare. But now, since the workers came out, which is the function as a service, luckily I don't do as much Lua anymore. And believe me, JavaScript is so much better than Lua. This is basically why this talk got created, because I want to show you how easy it is to deploy even security functions with a serverless architecture and FaaS. And I truly believe that in the future is basically for the serverless functions. Right, so talking points. We'll quickly go through what the hell is serverless, then function as a service, what it is, which kind of tools there are. We go to some examples and a demo. So first, what is serverless? I know that this is a very controversial term. Many people hate it. It's probably like a cloud used to be, right? Everybody hated the term, but then we kind of got stick with it. So for the sake of this talk, let's basically define the serverless computing as a concept of deploying and running applications without the need to provision, configure, or manage infrastructure, the underlying infrastructure. So this is considered to be the next gen of the computing. And when we talk about the network-based serverless, this is really a game changer for global applications, because as you can see, the networks, and usually like anycast networks, they have a huge coverage, right? And you can imagine the serverless computing to run on every single data center around the globe, which is, for example, like 10 milliseconds away from every, almost like 90% of the world's population. And that means that app can be deployed and run really close to the visitor. That gives us performance. So when we have a global app, what do we want? First, of course, we want to run it close to the visitor, right? So it will be fast. We want to auto-scale it. We want to run it when it's needed. That's actually, if you think about it, that's what the cloud was supposed to be. At least that's how I was explained to the cloud. So you have an app, you write an app, we just upload it somewhere to the cloud, and it magically runs it everywhere, anywhere where it's needed, right? Which is not the case. The second thing that we want when we do a global app, we want to pay only for the when the visitors get to the app. So we don't want to pay for the idle time, right? We don't want to pay when we are waiting for the visitor and actually not executing any functions, not serving anything. And the third thing is that we want something that is easy to manage. So if we are an e-commerce website, or e-commerce business, we don't really want to build an infrastructure like a infrastructure as a service company, right? So we want to focus on our business logic and on our e-com instead of doing the infrastructure. Right, so what kind of models do we have now? So if you have an app, how can you deploy it, right? So there is no silver bullet. I don't want to say that functions as a service are better than on-prem. Every model is good for its own use case. So on-prem is, of course, the oldest one. It even started with like one machine per function. So one box was email server, second box was web server, and then you had to manage 2 boxes, and you also own them, so you pay by machine. So you purchase the whole machine and you have to manage it, hardware, firmware, operating systems. Then VMs and containers came, which actually helped a lot. So you could have like one machine and then run multiple services on top of it, but still you would need to also manage VMs, containers, and the application itself. So also all the dependencies, etc. Right. So the tendency now is to basically switch from the on-premise. So based on what I see at my work, but still, like it's not that you must do, and it's not like we have to shame people who are still on-prem. At my previous work, I worked in the infrastructure, in the software company, in the infrastructure team, and we had in-house built in-memory database, which required really high-end servers with the 6 terabytes of RAM, and we could not buy those, we could not rent those servers anywhere, or we could not get something in the cloud, right? Because it would be either too expensive, or the majority of the providers actually didn't even have the option. So we had to buy those servers, and it was cheaper for us to actually manage the team, to hire the team, and to manage those servers ourselves, other than try to figure something out with some vendor. Yeah, so in our case, it made sense. So we were buying those servers and building everything on them. And then at some point we realized that besides the application itself, besides the software itself, we also put on those servers everything, like all the internal stuff, basically all the Jenkins and stuff like this. And it actually doesn't worth it, because those high-end servers that you have to maintain, it takes more work than to maybe spin something up in the cloud and then just run it from there. So we also started to at least migrate all the services or microservices that do not require the high RAM to the cloud. So the next thing is the infrastructure as a service. This is actually what is considered to be the cloud mostly, I think, but it's still yeah, you can either rent a full server, or you can rent a virtual machine on a shared physical box. You don't need to manage hardware, right? You only need to worry about the OS and the application, but you still, it's not the cloud, right? It's still somewhere in some region, and you know exactly where your data is, right? So it won't scale. Then some companies like Heroku went even further. They started to offer the platform as a service. So platform as a service simplifies the application deployment. So you can deploy the app, and the cloud will just worry about the rest, right? So about the servers and how to maintain it, right? So right, so you don't even have to worry about the operating system. And but the most platform as a SaaS options actually even can auto-scale at some point, but usually it's auto-scaling in the same region, right? So they can spin up many machines in the same region to handle the load, but they won't scale up geographically. And lately, so the new black, function as a service, I think Lambda is the most famous one. This is basically a concept of serverless computing via serverless architectures, right? So software developers can leverage this to deploy individual functions, individual pieces of business logic, which and you can expect the FaaS to start really quickly and to in some milliseconds, right? And then shut down immediately. So when the function is needed, it's being run. When it's not, you don't pay, and you pay for request. And compared with the FaaS, so you don't care about anything other than the business logic, same as in FaaS, but in FaaS you still need to have at least, probably in the majority of cases, you need to have at least one machine that is running, right? And then it can auto-scale, and you still pay for the idle time, and you pay for per hour running, and in FaaS you actually pay per request. So when the function is done, you paid. Right, and also imagine now functions as a service at the edge. So all of those data centers you saw on the previous slide, if the function as a service would run on any of those, and on those which is faster to the user, so this is crazy fast, right? And in case of Cloudflare, for example, the deployment and auto-scale, right, it takes under 30 seconds to actually distribute this script across every single data center, across like 200 data centers. Right, so all the big players actually have somewhat the function as a service, right? So AWS has Lambda, then Microsoft, Google, Cloudflare, I think Akamai is also trying to get into the living train. So everybody tried to give something like this. This is a screenshot from some benchmarking website, which I really don't like, because I don't think that all of those functions, all of those services are really different. And you actually, if you plan to pick your own service, it's better if you test it yourself with your own application, with your own users, with your own scale, right? Because some of the functions can actually be better for you than the other, and you will have your own benefits and minuses, right? So don't believe this one. And also, like, if you notice, if you open this website or some other website from time to time, the numbers actually change. And the number change, for example, on the number of data points that the test was run at. So I think like the top ones usually the Lambda and the workers, but sometimes they jump. So one is faster than another, and it's really like I wouldn't trust this test. Like how did they count it? Right. So I mentioned the edge a couple of times. So what is the edge actually? Right. So it's easier to think about it. So for example, like Lambda at edge and Cloudflare is the FaaS services that are running at the edge. And the edge is basically the third place to run the code. So historically or traditionally, we have two places. We have browser and we have origin server. One is very secure. It's like right near you, hitting you up at night, but you know exactly what is there, but it's really far from the visitors. So the performance is bad, right? Very secure, but bad performance. With the browser is really fast. It's really close to the visitor. It's just right there, but it's not secure. You don't know what is happening there. So edge and like different CDN providers, they basically give you the edge. So all of their data center nodes, which is something which can offer something in the middle, right? So it's much faster than the server, because it's really close to the visitors, and it's much more secure than the browser, because this is a company you trust, right? And they have professionals who actually look into the security of those services. Right, and then like deploying the FaaS at the edge, so not all kind of apps can be deployed in such fashion, at least now, but some of the apps and many microservices can even now. And if we, now we're starting to move towards my demo. So I use Cloudflare Workers, of course. and let's maybe, I want to take a moment to explain basically how the Cloudflare and the workers work, so you will understand the demo better. So we have an anycast network. We onboard via DNS, so all the visitors actually come to Cloudflare first, because they get the Cloudflare IP address. And then we can put a worker there, some other configurations, and then either we can return something from the worker right away, right? So we don't have to have the second part, or we can go fetch something from the origin, or we can go to any third-party providers like S3 bucket or some database and fetch the information from there. Okay, and when we were building workers, we basically were focusing on two main things. So we wanted security, because people are giving us their code. We want to be sure that their code is secure, and we also want to make sure that the company itself is secure, because the people are running code on our servers. And then the second one was performance. So we wanted to be faster, at least faster than Lambda, because this is like why would you do the second Lambda, right? Right. So what we decided to take, we decided to take V8. So why reinvent the wheel when you can just take something instead? So V8 is JavaScript engine developed for Google Chrome. It's actually optimized to load and run the code quickly. So if you're sitting in the browser and waiting, you don't have much time, right? If the page doesn't load within like seconds, you just go to a different page, right? So different vendor. So yeah, so in general, I think like what we saw, the V8 loads and runs under 5 milliseconds. So that covers our performance requirement. And when it comes to security, so Google has been developing V8 for more than 8 years? 10 years, wow, cool. So the browsers are really hostile environments, so you kind of have to focus on the security, right? So what we did is we took the browser JavaScript engine and placed it on the server. So of course, we added like a couple of sandboxing layers on top of that. We added various timeouts on the CPU, input, output, wait times. We also disabled some timers, counters, which can be exploited in attacks like Spectre. But if you ask me how secure is V8, so nothing is secure, never. You just, like, nothing can be secure possibly, right? So you have to just, the only thing that we can do is we can patch things, right? We can just try to make it as secure as we can at the moment. So Google is working on securing V8. We are working from our side on securing our environment with V8. But yeah, internet was never meant to be a safe place. Like, it was never built secure from the start. So the only thing that we can do is now patch. And I think like the same questions, same issues are with any new technology. So I remember when the VMs started to raise, like, all the people also hated it because no, you cannot put different applications on the same machine. It's not secure. But with time, and I'm pretty sure that this technology as well, with time, we will get there. So personally, I really believe, I really trust Google and Cloudflare, and I really believe that this is the good future for us. Okay. So what is good in the V8? The other nice thing is that it's built on isolates. So if you, like me, have like lots of tabs open in Google, in Chrome browser. So as I understand it, or as I see it, so V8 engine basically separates each browser tab to its own process and then runs all the tab scripts in the same isolation, right? So the scripts from one tab cannot actually refer to another tab. And same with Cloudflare Workers. So whereas we place, so if we would place scripts in a virtual machine, like for example, Lambda also works this way, so it would be one script per process. Thus we have the context switch. So, and also it needs to start every time on each request, right? So it needs to shut down and has the cold start. So that was too slow for us because, well, I mean, we already have Lambda. We don't want to be the same speed. We want to do something faster, right? So with the V8 isolates, what we can do is we can load multiple scripts. So each of the scripts in a single process is a different worker. And we usually group them in a way whether it's like scripts from a single customer or, for example, bunches of customers of the same tire, right? And then we can also monitor them and we can check their behavior. So if we see some of the isolates or some of the workers misbehaving, so if we see increase of errors or some weird spikes in the CPU usage or requests, so we can just kill this isolates, kill this worker, and just spin them up on the next request in a different virtual machine. And also worth mentioning that all the workers currently run after all of the security in the Cloudflare is passed, so that also helps us to get, not to get any malicious or bot requests coming to the function. So typical cases, everything starting from adding, removing headers, maybe managing the CDN, up to building own microservices or even applications in the workers. So first, quick example, injecting security headers on the fly. So there is a really cool researcher called Scott Helme. He has this website which can check if your website has security headers, or actually which security headers it does and does not have. So he was one of the very first users for workers, and this is like the proof of concept that he did. So this is the whole script, right? And it maybe takes you 10 minutes to write the script. less for people who are familiar with this, right? And then it takes 30 seconds to deploy to every single data center in Cloudflare. So you can start using it on every single location after 30 seconds. So it takes 10 minutes, 30 seconds to basically insert any headers, any security headers, update your course headers, your security. And if you're one of the people who thinks, like, is she really talking about hidden security headers? I can do it in Nginx in like no time. Well, yes, but think about the GitHub pages or Heroku or places where you either don't have the access to your web server configurations or it just would take too much time because you don't have the access and you're just frustrated and you just want to do something fast. And with Workers or with any like this kind of FaaS service, you can deploy this really quickly, and it doesn't matter how many origins do you have after this, and it can be different vendors, different web servers, different cloud vendors or on-prem vendors or a full mix of whatever, and you can just with one script, you can deploy it to every single one. Right, second one is personally my favorite, is the custom authorization and authentication. One of the smallest examples is the access token validation. So you can build like an API gateway easily. By default, workers are actually stateless. So we do reuse the, like if the connections keep coming, if the requests keep coming, we can actually still have the worker in the memory, so the isolate in the memory, so we can reuse it, so it can be stateful for a little bit, but then it can be killed at any point of time, right? So, yeah, so in order to make your function truly stateful, we introduced the key storage, so key value storage, and you can write and read to this storage from inside the worker, or actually through an API, as you wish. And if you write in one of the Cloudflare data centers, again, under 30 seconds, you can read it. And actually, usually it's less. Usually it's like 2-3 seconds, but we say under 30 seconds. You can read it from a different data center straight away. And the quote, again, looks really, really small. So this is the code on the right. On the left, you can see the API, or basically the curl command. So what the code does, it gets the account ID, it gets the token, and it just checks it against the key storage. And then it decides either you proxy this request or you just decline it. Okay, demo. Right. So for my demo, I started learning workers, and I thought, like, okay, what can I do for me, for myself? Something interesting. So I decided to do authentication authorization at Edge, and at home I have the home security camera, which is done with a Raspberry Pi, and I wanted to just stream it somewhere, but protect this place, right? So I would be able to just go to a website from anywhere in the world, just authenticate, and then see what's happening in my home. And if at least maybe not fully authenticated, and I also wanted to authenticate manually, right? So I wanted to approve every single visitor, or for example, do some whitelist, but the whitelisted users, I would want to know, for example, yeah, like a certificate, right? But I would want to know that somebody has logged in. So this is the schema. A request comes in, and I want to have like 2FA. So it would come into the access, which is one of the authentication on the Edge products of Cloudflare. So I log in there, and if I'm allowed, the request will then come to the worker. The worker sends a message to Telegram, which is a messenger like WhatsApp, right? But a secure one. It doesn't hand over the encryption keys to the government. Right, and the worker triggers a client-side script that is constantly checking for the reply. And when the admin, well, me, replies to the Telegram message, this is pulled via the webhook to the same worker, where we basically write the message to the KV, and then our browser scripts finally gets its approval and basically decides whether to deny this visitor or to approve them, so basically start proxying the request, so to fetch the content of the page. Okay, so this is how the UI looks. You can also do there are preview and Chrome DevTools. Yeah, I'm also going to show you my script. Give me a second. And I'm going to have a demo video. I'm not as risky as Matteo. I don't believe in demo gods. They don't love me. Okay. Let me find my script. Okay, cool. So that's the script. It's not really big, but it's enough. That's the whole function. So I can, yeah, if anybody is interested, I can show this. That was a really difficult one. So, and I have the video. Yay. Okay, let's play. Full screen? No, maybe? Full screen? That doesn't want full screen. Oop. Almost. Cool. Sweet. So I have my page, right, with a super secret admin login. And I also have on the left, I have my Telegram chat. So with a special admin approval. And then when I click on the page, I get to the access. So if you notice the URL, it's cloudflareaccess.com, so it has nothing to do with the server itself. So that's something that is happening on the edge. And basically with Cloudflare Access, what you can do, you can just get any IDP. So either SAML or like any cloud solutions like G Suite. You then create the access policies. Good stuff is that you can do the mutual TLS, is when you generate a client certificate and you add it to the browser or to the command line, and then you don't even see that because the SSL certificate is authenticated, basically compared, and then you just pass through the page. So I did the very simple one. I didn't connect it with any IDP. I did like one-time PIN for this demo. So I input my email, I receive, let me maybe pause it. Stop. So I input my email, I received a one-time PIN in my email, I input the PIN, and then I get the cookie, basically the passage cookie. And the sessions you can also define, right? So for example, give every visitor 30 minutes of the passage. So what happened next? So this awaiting authorization page. So this is already the worker, right? So we came to the worker. It sent a message to the Telegram real quick. And then what we started getting, so the worker generate, or actually the client-side script started to generate those requests, right? So request to some specific URL and gets the 403. So then, as we wait, we need to reply to the exact message because we want to approve this specific visitor. And this is actually being done in one of the data centers, right? So the webhook is read in one of the data centers, and then the worker or actually it's writing in one of the data centers, and this one is reading from the KV in the other one. And then you basically get to the site page. And I didn't put my stream here because I didn't want to put it to the demo. And if you look at the cookies, so what we have there, we have two cookies. The CF authorization cookie, which comes from this one-time PIN, and it has 30 minutes expiry. And then we have the worker 2FA token as well for the worker authorization. So if I got approved once, and then we can also do maybe TTL in there, so then I will be able to just, for half an hour, I will be able to just go to this page without any further authentication, right? And then in the worker script, I also have some whitelists. So for example, if I'm checking it at work, so my work IP, and it's IPv6 because we use IPv6 at work. This one. right? So whitelist IP, then I just put a log in the Telegram message that, hey, somebody has just logged in. These are the details of this request. And it got like whitelisted approved. Yeah, or you can do something, some other whitelist. So for example, you can see like a bot score from the bot management solution. So which is like machine learning that just throws you the guess if it's a bot or a human. Or something else. Okay. And conclusions. And we can close and go drink. So function as a service, what we've learned. So it reduces the operation overhead for security upgrades. It lowers the operational expenses. It simplifies development experience. It's running fast on the edge improves performance. Right, because it's running close to the visitor. And then if you're not ready to go full serverless, and honestly nobody is, with rare cases, so start offloading single functions built incrementally, because that makes sense, at least for many of the enterprise customers that I work with. It does make sense. It does make things easier. Thank you.